Okay, so we've been talking about graphing lines, writing equations of lines, and all of that kind of stuff. And so it makes sense for us to turn our attention and start talking about particular types of lines, especially when we graph them together. So we'll take a look at parallel and perpendicular lines today. Now, by the time we're finished here, you should be able to determine if lines are parallel, perpendicular, or neither. And you should be able to write equations of parallel and perpendicular lines. Okay? And you see the standards that we're going to cover there. Okay, so first things first, let's do some exploration. Let's graph these two lines. Okay, I'll give you a second to do that. And then start the video again, and you can stop the video, start the video again, and you can see what those graphs should look like. Okay, did you get this? Right? First line start at 1 on the y-axis, and then we go up 1, right 2, up 1, right 2, and you can make as many points as you want, but you keep walking through the slope, up 1, right 2, or down 1, left 2, to continue to get all of those points. Now the second line, we're going to start at -2 on the y-axis, and we go up 1, right 2, up 1, right 2, because the slope is 1 over 2 as well. Now, since we're starting at two different points on the y-axis, but we're walking to the next point the exact same way, hopefully it makes enough sense to say that these two lines are never going to cross. That's your question there in your notes. That's your question there in your notes, is are these two lines ever going to cross? And the answer is no. Now look at the two equations, here and here. What do they have in common? What's the same about them? Well, hopefully you're looking at that and saying, well, hey, look, the slopes are the same. Okay? The two lines that never cross are parallel lines. And apparently it looks as though if the slopes are the same, then those two lines are never going to cross. That makes enough sense. These two lines have the exact same steepness. So they're angled the same. So therefore they're not going to touch. Okay? That's exactly what parallel lines are. Now, the mathematical definition of parallel lines are lines that are in the same plane that never intersect. Now, same plane, the importance of that will be stressed upon you in future math classes. For right now, it's enough to say that two lines are parallel if they never touch or never cross. As we just discovered, parallel lines have the same slope. For that reason, all horizontal lines have a slope of 0, so they're going to be parallel to each other, and all vertical lines have an undefined slope, and so all of those lines are going to be parallel to each other. Okay? All right. So let's go through and try to determine if two lines are parallel. Now, if we were to try to do this through a graph, right? If I gave you two lines like this and asked you if they were parallel, it would be kind of difficult to tell. You might be able to say they appear to be parallel or they appear not to be parallel, but we wouldn't know for sure, right? So what we do is we use the idea of the slopes being the same. So, are the following lines parallel? In other words, do they have the same slope? Well, you have to be able to find the slope, and the easiest way to do that is to put these guys in slope-intercept form. Make sure that y has been isolated. This one has, so the slope for this guy is going to be -1/6. This guy's not, so we got to divide through by 6 to get y isolated here. And so we get -1/6x plus 1, and so the slope for this guy is -1/6. So yes, the slopes are the same, so these two lines are parallel. Okay? Another example for you. Stop the video, take a couple seconds, figure out the slopes, and decide if you think these two lines are going to be parallel. Okay, so what'd you come up with? The slope for the first guy is 3/4. And then we subtract 4x here, 4x here. We've got to get this guy into slope-intercept form, which means we have to get y by itself. Then divide through by -3. Okay, and so the slope for this guy is 4/3. So are these two lines going to be parallel? The answer is that's no. These slopes are not the same. So these lines are not going to be parallel. Okay? All right, we got one more for you. So again, here, 6x plus 2y equals 8 and 4y equals -12x plus 5. Are those guys going to be parallel? Get them in slope-intercept form, and then find the slopes and make your decision. And again, you can stop the video to do that, start it again to check to make sure that you're getting the right answers. Okay, what'd you come up with? Hopefully this. Okay, that's getting y by itself for both those equations. The two slopes are going to end up being -3, and so yes, they're going to be parallel. And again, if you had to explain why, you can simply say the slopes are the same. Okay. Now, the other objective for today was to be able to write the equation of parallel lines. And so, for example, here, if you want to write the equation of a line that goes through a particular point and is parallel to a particular line. So I want to write the equation of a line that passes through the point 5, 12 and is parallel to this line, to the graph of this line. Okay, you have to remember, we talked about before, what two things do you have to write the equation of a line? And those two things are the slope of that line and a point that's on that line. So right now, since we know that our line goes through the point 5, 12, that's going to be a point on our line, so we're going to use that for our point. Our slope, we don't know what our slope is yet, but we do know that our line is parallel to this one. And since the slope of this one is 3/2, that means that our slope is going to be 3/2. Right? And so now we're going to, and the reason why we need a slope and a point is because now we're going to use the slope formula to help us write our equation. Slope formula says m equals y minus y over x minus x. And we're going to plug in the slope, which is 3/2. We have a y. Remember that the y's and the x's on this side are just points. So we have a set of coordinates, an x and a y. So we're going to plug them in here. So we go y minus 12 over x minus 5. Okay, so we're just going to plug in these 2 points right here. Now, we've got to get y by itself, so we cross multiply and start doing some algebra. Remember that you distribute the 3, so we go 3 times x minus 5 equals 2 times y minus 12. Distribute. You get 3x minus 15 equals 2y minus 24. Then we add the 15. Oh, wait. No, we don't. Sorry, I'm trying to get y by itself. So we add the 24. So 2y equals 3x plus 9. Then divide through by 2. Bring this up here. And your equation turns into y equals 3/2 x plus 9/2. Okay? Hopefully that makes enough sense. So now you can try. Remember that you have to have a slope and a point on the line in order to write the equation. So go ahead and give it a shot. Stop the video. After working it out, start it again, and you can see what you should have done. Okay, all right, so we need a slope and a point. We have a point on the line that's 3 comma 6. And for the slope, I know that my line is parallel to this one, so I'm going to find the slope of this guy. So I got to subtract 5x, get 2y equals negative 5x plus 7, and then divide everything by 2. And so the slope for this line ends up being negative 5 over 2. So the slope for my line is negative 5 over 2. I'm going to plug this into the slope formula, get y minus 6 over x minus 3 over here. Cross multiply and go to work. So distribute negative 5 times x minus 3 equals 2 times y minus 6, and distribute negative 5x plus 15 equals 2y minus 12. Now we're going to add the 12 to both sides. Negative 5x plus 27 equals 2y. Now divide everything by 2, and your equation turns into y equals negative 5 halves x plus 27 over 2. Okay? Piece of cake. One more for you to try. Practice one more time, and we'll show you what you should come up with. What'd you get? Did you get this? Okay, so the slope of our line is going to be 2. The point goes through, a point on the line is negative 3 comma 1. Use the slope formula, do your algebra, and you should come up with y equals 2x plus 7. Okay? All right. Let's turn our attention to something else now. Let's try this again. Let's graph 2 lines on this coordinate plane. Okay, remember, y-intercept tells us where to start, slope tells us how to walk to the next point. When you graph these 2 lines, you should be able to come up with this, right? So for the first line, start at negative 1. And then slope tells us to walk up 1 over 2, up 1 over 2, and we can keep going. But that's where that line came from. And then the other guy, we started at positive 1 on the y-axis. Our slope is down 2, right 1, down 2, right 1, and so we can graph the line there. Okay? Now, do those 2 lines cross? Certainly they do. As a matter of fact, those 2 lines end up being perpendicular. Okay? And if these 2 lines are perpendicular, now look at the equations. Okay, compare and contrast the 2 equations now. Well, certainly the y-intercepts are different, and that is important. But we worried more about the slope before, so let's do that now. Look at the 2 slopes. One slope is 1/2, where the other slope is negative 2, or negative 2 over 1. That's interesting. These 2 slopes are what we call opposite reciprocals. If that's the case, then we have some definitions here. 2 lines are perpendicular if they have opposite reciprocal slopes of each other. Okay, again, just to take a look at a graph, it's too hard to tell if 2 lines are going to be perpendicular. So we check it and we look at their slopes. We can use the equations of those lines, and we use the slopes, and this is how. Opposite reciprocals. Another way to think about opposite reciprocals is we need to be able to flip it and switch it and get the other slope. So start with one slope, and you should be able to flip it and switch it to get to the other slope. Flip it means flip the fraction over. Switch it means switch the signs. So if I wanted the opposite reciprocal of 3, or in other words, if one line has a slope of 3, then the slope of a perpendicular line would be flip it, so 3 over 1 flips to 1 over 3, and switch it and change the sign. Same thing with 2 over 5. If the slope for a line was 2 over 5, then the slope of the perpendicular line would be negative 5 over 2. And for number 3, the slope of a line was negative 1/2. The slope of a perpendicular line would be positive 2 over 1. Number 4, if the slope of a line was negative 7, the slope of a perpendicular line would be 1 over 7. Okay? Now, horizontal and vertical lines are perpendicular to each other, and I think it's pretty easy to see when you graph, but I offer up this as a proof. We know that the slope of a horizontal line is 0, so I can write it as 0 over 1. Okay? Now, if I were to flip this slope, I'd get 1 over 0, switch the sign and make this negative. Well, it doesn't matter. Negative 1 over 0 is undefined. And so what we see here is that a slope of 0 and an undefined slope are going to be perpendicular slopes. And the slope of a horizontal line is 0, and the slope of a vertical line is undefined. So horizontal and vertical lines are always perpendicular to each other. Okay? All right. That being said, same as before, are the following lines perpendicular? Again, we can tell by the slopes, so we need to go find the slopes. Get this first guy in a slope-intercept form by dividing through by 4. And so the slope here is negative 5 over 4. The slope here is going to be negative 4 over 5. So no, these guys are not perpendicular. The slopes are not opposite reciprocals. Okay? We flipped them, but we didn't switch the sign. All right, so try this guy. Take a few minutes, see if you can figure out if these two lines are going to be perpendicular. Stop the video, and then start it back up again and see if you're right. Okay, so the slope for this guy, without even having to do any algebra, you could subtract 7 from both sides if you wanted to, but you don't need to. The slope for this line is going to be 7 over 9, the coefficient on x, and the slope for this line is going to be negative 7 over 9. Are these two lines going to be perpendicular? And the answer to that question is still no. Because, again, the slopes are not opposite reciprocals. Okay? In other words, we switched signs, but we didn't flip the fraction. Okay? So not perpendicular. All right? All right. A different twist on this is we've got two lines here. Are these lines parallel, perpendicular, or neither? Well, it's the same process. We have to have the slope for our two lines, so we need to go through and find them. The slope for the first line is pretty easy. It's already in the slope-intercept form. It's 4. This guy, we have to add 4x to both sides to get it into slope-intercept form. Okay? And so the slope here is 4. Since the two slopes are the same, these guys are going to be parallel. Okay? Good. And it's because the slopes are the same. Now you try these. Stop the video, find the slopes, just make your decision, and then see if you're right. Okay, what'd you discover? The slope for this second line is easy enough to find. Divide everything through by 8, and the slope ends up being here, so the slope is 3 over 8. This other guy, we got to do a little bit of work to. Right, so we're going to add 2x to both sides, because we're going to work on getting y by itself. And then divide through by 7. And so the slope here is 2 over 7. These are neither parallel nor perpendicular. because the slopes are not the same and they're not opposite reciprocals. Okay? All right. One more for you to try. Again, stop the video, give it a shot, and see what you come up with. What'd you decide? Again, got to find the slopes. Okay, the slope for the second line is -6. You got to do some work to get the slope of the other guy, which is positive 1/6. And so these are going to be perpendicular. If you take one slope, flip it, and switch it, you get the other one. Okay, so hopefully you were able to determine that. All right. Now, if you, like we were doing before, if you want to write the equation of a line, so write the equation of a line, we're going to stop right there. Anytime you have something say write the equation of a line, we know that means we have to have a slope and we have to have a point. And apparently a point on our line is 2, 4. The slope of our line, well, we don't know yet, but we do know that our line is perpendicular to this one. And the slope of this one, okay, so since the slope for this line is 1/3, and our line is perpendicular to that one, then our slope is going to be -3/1. So we get the slope formula. -3/1 is equal to, just like before, y should be y minus y over x minus x, but we have a y and an x to plug in. So we get y minus 4 over x minus 2. Now we're going to cross multiply. We get y minus 4 equals, make sure you distribute that -3, we get -3x plus 6, and then we add 4, and so y is equal to -3x plus 10. Okay? Piece of cake, just like we were doing before. Here's one for you to try. Again, stop the video. Try it out. Remember, you got to find the slope and a point on the line and plug it into the slope formula. And then start it back up again and see how you did. Okay, how'd you do? You got to have a slope, got to have a point. -2, 5 is a point on our line. Slope. Well, we've got to distribute the -2 here. So what I'm doing is I'm trying to find the slope of this line. Subtract 3, subtract 3. This part doesn't really matter as much because the slope for this line is just going to be -2x. And that's really what I'm concerned about. If the slope for this line is -2, then the slope for our line is going to be flip it and switch it, or 1/2. Now that I've determined that, I'm going to go through, plug into the slope formula. 1/2 equals y minus 5 over x plus 2. Cross multiply. We get x plus 2 equals 2y minus 10. Add 10, add 10. You get 2y equals x plus 12. Now divide everything by 2, and our equation turns into y equals 1/2 x plus 6. Okay? All right. And you got one more. Again, pause the video, start it back up again once you're done, and see if you got it right. Okay, how'd you do? This is what you should have gotten. The point on our line is 1, 8. Our slope's -1/2 because the slope of the existing line is 2. Plug it in the slope formula. Do your algebra, and you should come up with -1/2 x plus 17 over 2. Okay, any issues with that, come see me. We'll work through it. In other words, homework's in Canvas. We'll see you guys next time.